Hello, and today I'm going to be talking about the fundamental theorem of calculus, which is, as the name implies, one of the most important ones you'll learn. So pay attention, I guess. And I wouldn't recommend you be absent from class when you cover this, but I felt like I just wanted to make an attempt to teach this, as it's one of the core theorems of calculus. So yeah. So part 1 of the fundamental theorem of calculus states that if your function f is continuous on the interval from a to b, then the function capital F of x equals the integral from a to x of f of t dt has a derivative df d capital F dx equals d over dx d over dx of the integral from a to x f of t dt, which equals f of x. And in case you don't know, capital F of x is just your antiderivative. So what makes this theorem important is that it relates your integration and differentiation as inverse of steps of math, and that's through this line here. You're finding the derivative of an antiderivative, as you can see here. So that just gives you your original function, so you know that these these processes undo each other. And the fundamental theorem of calculus part 1 also tells you that you can take the antiderivative of any continuous function. So this is definitely really an important function to know. That being said, however, you're probably curious as to what you can actually do with this theorem in terms of like problems. So it's actually really simple, like deceptively simple. So this is problem here: d over d of dx of the integral from 0 to x of 1 plus t squared dt. So since you're just taking the derivative of the integral from 0 to x of this function, it's just that function, except instead of t's you'll have x, and that's it. And you can also do this process with chain rules as your x. So let's say we have this problem: find dy dx if y equals the integral from 1 to x squared of cosine t dt. And what I recommend doing is making x squared into another variable. I'll make it u for this example. So u equals x squared. So let's write that again. So now we just do the differentiation with u. So y equals the integral from 1 to u cosine of t du. So sorry about this, my camera just needs to focus. So dy dx is equal to cosine u, just doing the same process I did here. And so now I'll plug back in my u. Oh, but of course when you do something like this, you have to multiply it by du dx. In this example, my d over dx was just 1 because it was just x, and the derivative of x is 1. So, you know, it's implied that I'm multiplying by the derivative, but it's just 1, so we don't write it down. So now I substitute my u back in, so cosine of x squared times the derivative of x squared, which is 2x. And that's it. You can also apply the your derivative rules, your definite integral rules that I covered in the last videos with these types of problems. Just to give an example, y equals the integral from x to 5 of 3t sine t dt. Find dy dx. So your x is on the lower bound, and in order for the calculation to work, it needs to be on the upper bound. So we'll just do what we did in one of our integral in the previous video and just flip the bounds and add a negative sign. So the negative integral from 5 to x of 3t sine t dt, and just dy dx equals negative d over dx of the integral from, oh sorry, my bad, equals d over dx of the negative integral from 5 to x of 3t sine t dt, and you just do what you did for these other problems and just plug in x for the t, so negative 3x sine x, and that's it. I guess that's pretty much it for the part 1 of the fundamental theorem calculus. But one thing I would like to note is that this only works if the bound, the lower bound, like the 5 here, the 0 here, and the 1 here, it only works if that lower bound can actually be defined in your function. For example, if you were to do something like the find dy dx, if y equals the integral from negative 3 to x of ln of x, ln of t dt, you can't actually do this because you can't take the natural log of a negative number. So yeah, it would just not, you just can't do the fundamental theorem calculus like that. And I would keep, you probably won't see a question like that on your tests or something like that, but the AP exam, probably they ask some sort of like random questions like those out of the blue on multiple choice sometimes, and I forgot about that during a review test, and I got that question wrong. So, you know, a lot of people did, so you should be proactive and remember that for the future. My voice is getting kind of tired, so I think I'm going to leave part 2 to another video.